Okay, respected invited speaker, Professor Javed Iqbal sir, dear faculty friends and dear students, a very good afternoon to everybody. So in our ongoing EVS lecture series, today the invited speaker is Professor Javed Iqbal. So it's my pleasure to introduce Professor Javed Iqbal. Currently, Professor Iqbal is working as an assistant professor in Civil and Environmental Engineering Department at Birla Institute of Technology, Mesra, shortly known as BIT, Mesra, located at Ranchi. So Professor Iqbal completed his master's and PhD from the same institute. Before joining BIT Mesra, he was working as an environmental engineering different consultancies. So in the year of 2008, he joined at VIT Mesra as a faculty member. His area of research includes water and wastewater treatment, optimization and air pollution monitoring and modeling. He published many national and international journals. So with his experience of research and teaching in these particular areas, so I'm very sure that this lecture is going to be very interesting. So today he'll be delivering the lecture on the topic solid waste management processes. With this, I welcome Professor Iqbal to deliver the talk. So it's over to you, sir.
Thank you, sir. Thank you for your nice introduction, and good afternoon to all of you. And it is a very sunny day here, although it is a cold winter in morning and evening. So I hope that you are safe at homes, and the way we are passing through the pandemic, the time will over. But meanwhile, we will continue. The life shouldn't be stopped or the goal shouldn't be hindered. So we'll start with this aim. And with this, sir, I would like to put off the video, then I can go ahead. Should I put off the video to make it more convenient?
No need, sir. It's fine. So you can switch on the video.
Then fine, if it is okay with you.
It's
okay,
fine.
Let us start with this. Solid waste management processes, since I have been asked to take this topic, and it contains the different constraints, like as per your syllabus, it is solid waste management process. So I kept the title as it is, and the subheadings are like solid waste generation from an area and its management processes by government. So I have tried to keep the things from the CPHE manuals, so that what you are looking exactly, that how the government agencies are enforcing it, or how this Ministry of Environment and Forest for Climate Change is taking care of this solid waste management in India, particularly in India. Apart from this, we are having some focuses on the usual techniques which has been adopted worldwide, and composting, importance waste management. So what is the importance of this composting? So, and possible reducing, reusing and recycling techniques at home. With these objectives, we'll try to drive the lecture around it, so that all three components should be covered, and the content of this module should be covered over here in 1 hour of limited time. So as we know that solid waste is a waste which is solid in nature, and when it is generated from the municipal area, that is the area which falls under the municipal corporation, it is termed as a solid waste. Why it is called a waste? Because waste is a constraint which has no longer any economic value for the users. For example, you have bought something from Amazon or Flipkart, or you have bought some fruits or vegetables. You have used some part of that, and rest you have discarded, and it has no meaning for you, or it doesn't have any economic value, or the wrappers or packaging which was something you got, laptop or mobile, etc. So it becomes useless for you. So you basically discard it. That what I'll do with these packaging and all. So basically that makes the sense of waste. And this is the point of generation of waste. So whatever waste has been generated from households, commercial buildings, or the hospitals which falls under the municipal corporation area is termed as a municipal solid waste. And Government of India brought a rule that is under Environmental Protection Act 1986, which is called as Municipal Solid Waste Management and Handling Rules 2000. Under these laws, we have to, or the authorities, basically these urban development authorities or the municipal corporations are the authorities who are responsible for the proper collection, transportation, and disposal of this municipal solid waste management. As well as you will see, or you'll find that every cities, wherever you are living, since you are in VIT, it doesn't mean that you belong to that very place. You are from all the part of the country, or maybe from the other part. So you must have seen at your homes that you are having at least two bins concept. That is, the biodegradable fractions are kept separately and the non-biodegradable fractions are kept separately. That is, at least blue and green bins are there for separation of the solid waste at the source. If we will not take care of these solid waste, so what could be the possible threat to the environment or the public health? So let's see one by one that what could be those things. Direct health risk. So who are the person who will be directly affected by these risks? So of course, these persons who are working in the field, who are in direct contacts with these waste, those who are in handling, processing, or those who are in collection, everything. So these persons are actually at direct risk and a specific risk. So handling waste from hospitals and clinics. For example, there is a biohazards in these hospitals or clinics. So if proper handling procedures are not followed as per the biomedical handling waste rules, so there is a chances of contamination, or as well as the persons who are exposed, direct exposure from these waste. Indirect health risks consist of breeding of disease vectors, because if solid waste is dumped somewhere, so it is a breeding ground for vectors, flies, rats, etc. So these also causes disease because of these flies, rats, etc. Now, so does it looks good if some solid waste is dumped on the roadside or in some highways or in some water bodies? Of course not. So it decreases the beauty, scenic beauty of that place and reduces the aesthetic value of that place. Air pollution. So burning of these waste causes air pollution because it burn, so it may contain dioxin or furans. So we really don't like these dioxins or furans which are containing these chlorine, or they are chlorinated compounds which are known carcinogens. So it may cause burning of the waste as well as release of the gases from the dumping sites, because if it is improperly disposed of, it means there is a anaerobic decomposition at the bed of the waste, and which may cause release of toxic gases or combustible gases like H2S could be there, or some volatile organic gases could be there. So that we don't want, that is a nuisance, and that is a problem for our health or environment and aesthetics all time. And we can cite all these things like traffic accidents because of this toxic spilled waste, or concentration of heavy metals in food chains because metals which has been entered into the groundwater or the surface water through the leaching may enter into the food chain by means of the plants and the animals and so on, or direct consumption of the plants or vegetables, etc. As well as this is not limited to here, it may lead to this contamination of groundwater and surface water. So what this CPHU manual says, so this basically we are here concentrated on this municipal solid waste management. So what it says, this municipal solid waste management involves the applications of principle of integrated solid waste management. So it is ISWM to municipal waste. So what is this integrated solid waste management? So it can be defined as the selection and application of suitable techniques. What is these suitable techniques and technologies and management programs? So basically, if you are talking about solid waste management, so it is, what is the objective and goals? What we will do with that? The basic thing, or any in like you are studying your any specific paper, if you are in civil engineering or in your electronical or electrical engineering. So if you are doing some designs, so the first thing comes in mind is the objective, or you are doing your BTech degree. So the very thing that comes in mind is your objective. What is objective of that particular thing, or what will you will achieve at the end? So that should be a specific one. Otherwise, you are going randomly, like all these municipal corporations or municipal authorities are moving on. And the selection of these suitable techniques and technologies will also dependent on these objective and goals of your solid waste management programs. So it will consist all the aspects, the economical aspects, the political aspects, the social aspects, the technological aspects. So we cannot avoid these things. What is this hierarchy of this integrated solid waste management as per this US EPA? So the US EPA says, and what actually we will go for is first reduction, source reduction. So if we can reduce the generation of the waste, so of course there is a less requirement of the space for dumping of the waste or the technical application for treatment of the waste. Just a moment. Just 1 minute.
Okay.
Just 1 minute. There is a lot of noise.
Sir, you can unmute, please.
Hello, sir. Excuse me, sir. You are. Excuse me, sir. Can you please unmute?
Sorry, yes, there is a lot of background noise that cannot be handled. So the next stage is recycling. So I have mentioned here that what this US EPA or this Environmental Protection Agency of United States recommend is recycling, means we are not throwing the waste as a discarded or unusable material. We are recycling it by means of some technical applications. And next one is waste combustion and waste transformation. That is, if we cannot recycle that component, so this US EPA recommend that it could be transformed into another form. For example, this composting, or we can reduce it if we don't have option of this, like this waste combustion in incinerators or by the means of incineration. And the least preferred method is your landfilling. That is the alternate or ultimate fate of the waste is your landfill sites. And if you will see the CPHE manual, so it states that to achieve this ISWM, we have to reduce the waste, that is at the source, and then effective management of waste is still produced after waste reduction. So this is basically minimized in one step. All these steps what this US EPA has recommended, because the basic thing in solid waste management or in any management process is same as the others. So when we wish to manage this solid waste, we have to find or identify the elements which are called the functional elements. So what are these functional elements which will be helpful in management of this solid waste? So first one is your waste generation, then waste handling and separation, storage and processing at the source, then collection, then separation and processing and transformation of solid waste, and then transfer and transport. Here in CPH manual, you'll find it as a waste storage depots and treatment and disposal. So let us take it as we ourselves as a generator, like this waste generation. So please don't try to be very much technical on it. Try to understand from the point of view that you are having some pen with you, and this is a old one, and that you have to discard it. So this is the point of generation. Or if you are using some vegetables at homes, so there is a peels, vegetables peels or fruit peels, or you are discarding any food, etc. So that becomes the generation. So if you will try to understand in this way, in a very practical way that we are experiencing day by day, then it becomes very easy to understand this functional element. You need not to go through any technical description. Of course, technical descriptions will come when you will go deeper into it. But for understanding purpose, you have to be practical one. So basically, if we'll try to see from this point of view, waste generation. So like I said, vegetable peels, okay, or this fruits or discarded foods from houses, or it could be restaurants. Restaurants are the biggest source of this discarded foods. So from here, this generation starts. So once, for example, these have been started, and like we are having these papers, boards, etc. We are having a lot of things over here. We have generated the waste. In offices itself, we waste a lot of papers and all. So let us start with that point. Then waste handling, separation, storage and processing at the source. So what this CPHU recommends, or this CPCB recommends, that the separation of these biodegradable waste from the non-biodegradable waste should be at the source of generation. Means if I am the generator, means I have generated these vegetable peels, fruit peels, or discarded foods, or these papers, boards, or plastic bags, etc. are there. So it is my responsibility to keep two bins, to keep there is a green beans. Say we are having a green beans where we have to keep these biodegradable waste, and there is a blue beans where I have to keep non-biodegradable waste. So this is how we can help the municipal authorities or the agencies to handle the waste very easily, because when you will reach to this, that is when the door-to-door collections is done. So what they do, that they need your beans separately. If you have kept the biodegradable fractions only in green beans, so they will empty the beans into the green side, and they will empty these non-biodegradable or these recyclable fractions in the other beans. So it makes easy, as well as this assortment or processing of the waste becomes easy. Means here itself, if biodegradable fractions has been collected over here, so that waste can be directly sent to the treatment site. For example, here say composting or vermicomposting or biome. So these fraction can be directly sent to this treatment site. So there is no need to go for another step. For example, this transfer and transport or this separation and processing. So this is the advantage. So the collection system may be different one that we will look later, but this is the collection that is from the horses, the vehicles that comes, or carts that comes with the small vehicles and collect the waste from the houses, and they send it to the waste storage depots. That is, we also call it a transfer station. Means the small quantity of waste are compressed and is sent to the separation and processing or transportation units, direct treatment and disposal units from these stations in a large or big size of vehicles. So this is the step that may be skipped one. As you can see, there is a direct link from this collection to the treatment or disposal sites, or from the collection if it is not assorted, or even if there is a assortion is done. So still we are having these blue beans which are having non-biodegradable fractions. So separation and processing of the waste, means like plastics, cardboards, papers, etc. can be sorted out, or ferrous, non-ferrous materials can be sorted at that places, and transformation of this solid waste into a new product by means of any thermal processing or bioprocessing. It could be anything that we'll see in the later step. And from there, it will come to the treatment site for whether it will go for this composting, vermicomposting, incineration, or pyrolysis. It could be any process. So, but it has to go through these stages, or depending upon the collection process. That is what I told you, that if you are going for the separate bins, so it will be very easy. And one very interesting thing that you may have noticed, that these rag pickers, I don't know whether it is prominent in all cities or not, but in many cities, and what we have seen, these rag pickers or the scavengers, actually they helps us very much in cleaning the environment, because what they clean is tin, iron, packets, cans, plastics, cardboards. Means what is meaningful, they will pick up and they will sell it out to the uh, recycling factories. So it helps in separation or processing of the waste very efficiently. So they are having very good role in the society. So once you identified that the thing is of no longer useful for you, so you have discarded, so it becomes a waste. And in India, in urban India, the waste generation is 54.75 million tons of municipal solid waste annually. We are talking about only municipal solid waste, means it falls under the municipal corporation area. We are not talking about the industrial area or others, which doesn't fall under this municipal corporation. So which is actually 1.5 lakh tons per day. And we are talking about only the organized sector. We are not talking about the unorganized sectors. So these are the government data only, and this is old data. It is not a new release data. And the generation of waste could range from 0.2 kg to 0.6 kg per day per capita, because it is well-offness of locality. Means rich people generate more waste and poor always generate less waste. The reason is that if there is some plastic or cardboard or some metal or cans, instead of throwing it, they wish to sell it to the vendors or the street vendors which collect these recyclable materials. So there is a pie chart which depicts the fraction of the different waste. So just have a look on it, that these paper and pre-boards, the food scraps, yard trimming, the plastic, it is our typical values. So what it consists of. So now, as per these CPHU classifications, like there are different ways of classification in textbooks also. But if you'll go through this classification, you will find that we are having this biodegradable waste. So all the waste which are organic and that can be composed by means of microbes are termed as your biodegradable waste. So these waste are basically waste generated from kitchen. It may be kitchen from the houses or the restaurants, or it could be waste from the food processing industries. So they are basically biodegradable, or any agriculture based industry generating waste is basically biodegradable in nature. So it could be anything: vegetables, flowers, leaf, fruits, paper. But it is having this another value, like this paper, it can be recycled. And the second component is recyclable materials. So basically this is a resource. This is a resource. Means if you are not cutting more trees or bamboos for this paper or boards, means you are saving it. You are saving the resource. So recycling these materials is conservation of the resource or increasing the resource, in fact. So this glass, bottles, cans, metals, whatever can be recycled. For example, this plastics. So what is this resource of this plastics? So means if you are generating more virgin plastics and you are generating in all this polythene and these PVCs and all, you are using excess of crude oil. So you know that it is a non-replenishable source, this crude oils. So what we try to do is recycle. So if you are using recycled materials, means you are lessening the burden on the environment as well as you are saving the resources. Another classification is inert waste like construction and demolition waste, dirt, rocks, debris, etc. This composite waste like waste clothings, tetra packs, waste plastics such as toys, etc. So it could be anything or mixture of these things. And next one is your domestic hazardous waste. We use a lot of things at homes like batteries, electronic gadgets, or we discard many of the part of the electrical gadgets. We use these pens, chemicals, light bulbs, fluorescent tubes, etc. So basically all these falls under the hazardous waste category. If we will not dump it along with the municipal waste, so basically which consists of a very small fraction of these solid waste can be saved from contamination. Because why we are saying hazardous waste means it is having any of the properties like toxicity or carcinogenicity or inflammatory, or it is uh, having some properties which may like explosive one. So if it is having such properties, so it is better to remove it at the source itself, so which will lessen the burden on the treatment facilities, as well as if it is going directly to dumping sites, so there is a less chances of contamination of the landfill sites, because if there is a leaching, it will contaminate the surface and groundwater. So waste handling and separation, storage and processing. This is a very important step, because how we handle, like I talked about it, this handling of the waste or the separation at the source itself. So if we are storing it separately, means the disposal or the collection becomes very easy. So it can be handed over to the authorities separately, and the biodegradable fractions can be separated in a green beans, or this recycled fractions can be separated in another units. Like examples are these. This is how these municipal solid waste handling sites look like. So there is a processing or this sorting is there in the plant. Collection system. So gathering of solid waste and recyclable materials. So once it has been collected at the homes, so it has to be transferred from homes to the collection vehicles. So these cost around 50% in the US, since we don't have data of India. So we are taking this, that it cost 50% of the total solid waste management cost. And if you'll come to the data, so collection efficiency in metro cities is around 70 to 90%, whereas in smaller cities this efficiency is up to 70%, 50 to 20%, means rest of the waste is discarded into any low-lying area. So this is seen You can see how this is done. You can see here these green beans for these biodegradable fractions and the blue beans for these non-biodegradable fractions. And this classification of collection system could be like this: horse to horse collection. Means these municipal authorities or personnel from the municipal authorities will come and collect waste from door to door. And another way is community, that we will dump the waste into the community bins and the authorities will pick up the filled bins and replace it with the empty bins. Another type of collection system is curbside pickup system, which is not prevalent in India. But basically what we do, we keep it on the outside of houses, and the authorities will empty your bins and leave the empty bins outside the door. And another system is that you have to deliver the bins to the municipal authority personals that comes for collection of the waste. They will not pick up from the doorsteps. And you can also classify it on the basis of mode of operation, like hauled container system and stationary container system. So in hauled container systems means a empty storage container will be kept by the municipal personnel, and the filled one will be taken to the transfer stations. Whereas in stationary container systems, the municipal authorities will come with the trucks and they will empty the containers and will keep back the dustbins over there. This is one schematic that how these stationary and haul systems work. This is waste collection with skilled labor in developed countries. Have a look on this. This is how they are emptying the bins from the doors or the curbside. Now the next step, we can see here this separation, processing and transformation of MSW. So source of MSW, it has been generated. So separation storage at source, you have different beams to collect it. So we are having these biodegradable fractions and remaining is your non-biodegradable fractions. So what is the fate of these biodegradable organic fractions? That has to be transferred to transfer station or the collection points from where it will go to the treatment site. For example, any composting or vermicomposting site. And what about the fate of these biodegradable waste? That is, it will go to the transfer stations, and transfer stations may, the secondary sorting is done. That is, it is segregated. For example, ferrous, non-ferrous, plastics, cardboards, bottles, or glasses, etc. are sorted over there. Then it goes to the recycling plants. So whatever is the recycled fractions are sent to the recyclable plants, and remaining components goes to the treatment units, or this ultimately goes to the disposal sites, and ultimate fit is your landfill sites. Sometimes it is that this entire waste goes to the recycling facilities, and it is job of this recycling facility to segregate the ferrous, non-ferrous waste or the other type of waste and send it to the respective units. The purpose of these transfer stations are that the waste are collected in a large vehicles, and it is compressed and transfer it into the treatment units or disposal sites. So basically here we termed it as a transfer or a storage depot. Like you might have seen in many cities in India that waste collected from households are dumped into these storage depots. from where it is collected into the large vehicles where it is compressed and sent into the treatment or the processing units. So this is one schematics that from dustbin to these small trucks to these stations, transfer stations to large vehicles, or these haul container systems to these vehicles, and transfer stations where sorting etc. is taking place, and after this it is sent to the processing plants, respective processing plants, and ultimately the remainder one is sent to the landfill sites. Now the next point is treatment and disposal. So that is in India, almost 94% of the waste is dumped into low-lying areas. So you can see the scenic blight over here, that there is a flies. Of course, there is a lot of microbes, rodents, and it is a ground for these flies and all. So there would be nuisance, there would be a lot of gases around it, on which there would be combustible gases, there would be toxic gases as well as. So except a few cities, you will find that the waste is dumped like this or little treatment is given. So most of the waste goes into these low-lying areas, which basically leads to the groundwater contamination as well as the surface water contamination. This is one of the diagram where this is these facilities are there. So what are the different technological options for treating and disposal of these solid waste? So basically these are your composting, vermicomposting, anaerobic digestion, biomethanations, incineration, gasification or pyrolysis, or plasma pyrolysis, production of refuse-derived fuels, and sanitary landfilling, which is the ultimate fate of the solid waste. So this is your as per this CPHE manuals, because you have been asked to go through this. So these are the options suggested by CPHE manuals. So sanitary landfill is different from this open dumping because it is a scientific way of dumping the solid waste, and which is controlled site. For example, here if we can have a look on this, this is the trench method and this is area method. So what is the difference between these two methods is that in area method, these are basically the low-lying area where there is no chances of excavating the land, maybe because of the high groundwater table or there is no enough soil, and it is already a low-lying area. And wherever there is a chances of excavation on removing the soil, we can put a trench, and as you see, we can dump the solid waste over here, and by means of bulldozer we can compress the waste, and later on we can cover it. This is called a daily cover. We can cover the waste so that there is no flies and there is no birds or harbor of the animals, etc., or animals will not feed on it. So this is called your cells. This is called your cell. So this is done in a scientific manner and it looks like this. So this is the final one, that it has been covered by this topsoil. So it looks like a flat ground. So this doesn't allow any contamination of groundwater or surface runoff because it is scientifically done, and there is a liners which actually stops the infiltration of the leachates from the bottom, as well as there is a daily cover and the final cover on the top. The biodegradable fractions of the solid waste can be recycled. Means these organic fractions which are biodegradable can be degraded into a useful humus-like substance which is called compost. So as per the CP, the amount of compost generation from each million ton of garbage is around 200 to 300 kg, which is a organic fertilizers. And you know that it is a very good manure. So what is advantage of this composting if I'll ask you? So the simple answer is that it enriches the soil as well as it helps retaining the moisture of the soil, and it suppresses diseases and pests. So this is all this beauty of this biocompost, and it also reduces the dependency on the chemical fertilizers. So you can count the things that how it is beneficial, as well as it increases the population of the good bacteria into the soil and the fungi, which actually break down the organic matter. And most important benefit that we can count it reduces the methane emission from the landfills, because if we are converting it into a humus substance which is having high nutrient content which can be used as soil amenders, means basically we are also reducing the emission of methane, which is a greenhouse gas. So these are the different stages that I'm not going, nor the mechanism. Few things that we need is while digestion of this organic matter takes place is important is the pH, the moisture content, and temperature. So the optimum conditions must be there, so such that these microbes can grow and they can decompose it. The optimum pH for this composting is 6.5 to 7.5. Moisture content is 50 to 60%, and temperature increases in during this aerobic phases to anaerobic phases, that can be seen from this graph, that initially the temperature is less. As the degradation or this aerobic decomposition takes place, the mesophilic bacteria participate up to 45 degrees Celsius, and beyond that these thermophiles replace these mesophiles and they dominate, and is at this temperature all pathogens are killed. So this is one of the most important benefit of this composting process also. And it takes around 3 to 4 weeks to generate the compost, but another 3 to 4 weeks may be required for the cooling of the compost, because this compost cannot be used after this digestion directly. It needs cooling. So this phase or curing or cooling is very important. This phase is important for the compost. So this compost can be used after this time. Advancement over this composting is vermicomposting, in which we use some sort of earthworms, and these earthworms eats, we can directly say that they consume this organic matter and excrete the manures, which is called casting, and these castings are rich in nutrients, and they are very good fertilizers. So as you can see that there are different type of earthworms around the world, and it could be burrowing or non-burrowing type of earthworms. In India, different species of these earthworms are used for vermicomposting, and there is a very limited application of this vermicomposting, and the compost made of by this process is more granular than the compost generated in your composting plants. So these are the steps basically that I cannot go right now. Details. As well as we can get resource out of this. Means if you will not see the municipal solid waste as a waste, so we can derive energy out of it, and the energy recovery is done by means of thermal chemical conversions and biochemical conversions. So let us have a look on this. Like there is a incineration process in which the combustible material are oxidized to reduce the volume of the waste under high temperatures. So this is very important thing, that combustible materials are required, high temperature is required, detoxification is taking place, as well as volume reduction is taking place. Detoxification, volume reduction. So it is almost 10%. All is all the toxins are detoxified, like biomedical waste is totally detoxified over this under high temperatures. The temperature may be as high as 1200 degrees Celsius, as well as the heat produced in this process can be used to generate the turbines, and which can be source of energy to run the plant. In another process, this in anaerobic conditions, the biodegradable fractions can be decomposed to generate the methane, which is a biogas, and this biogas can be used for generation of electricity or can be burned, like you might have seen the gobar gas plants, etc., which is used as a fuel. So this is the flow diagram over here, where this you can see anaerobic decomposition is taking place. The solid products are separated and this biogas is separated, and this biogas can be used to generate the electricity. That is the process of electricity generation is there, and I have to skip. Another process is pyrolysis, in which under controlled conditions, mean in absence of oxygen, we reduce the organic substances, or we degrade the substances under pressure, and the end products are your char, which is solid one, tars, which is liquid one, and gas, which is gaseous form, already in gaseous form. So this char is a end product, tar is a end product, or this is oil which can be used. This gas can be combusted. So pyrolysis is also a very useful process, as well as one very important thing when we are doing it at high temperature over here, like you can see here, this quenching is done. So we cool down it to lower temperatures to stop the formation of dioxins and furans that we don't want. We don't want these substances. So quenching is the process by which we can stop the formation of dioxins and furans in this process of pyrolysis. Waste management practices there is the importance of these 3 R's, that is reduce. that we talked about it. What you can reduce. So it is best one. If you are using something that can be used repeatedly, then it is the best thing. Or if you can avoid excessive wastage of things, means you are reducing the generation of the waste, reusing the things. For example, if some things has been some wrappers were there, or you have used these bottles, this diagram, you can see how this is done. And I have seen it in Tata, in Steel City, that people used to garden or made this window garden with the help of this bottle. So these bottles can be reused, or the papers can be reused, or this cardboard or the glass, many things can be reused. So reusing means preserving the resources and recycling. So if we cannot directly reuse it, then we can transform it, or through a process we can manufacture the other things. For example, best example is your plastic recycling, or another is your composting, है ना? Or paper recycling, है ना? या फिर any metal recycling. So there are many things that can be done. So this can be done like recycling, metal of all these things can be done. This is what we can do this with these 3 R's, these green leaf utensils, these plastic bottle gardens. You can try all these things. This is basically not a waste. And this Diwali is over, but still we are having Christmas ahead, though enlighten these recycled bottles and recycled old cloths. So this can be used for this doormat or etc., which is really being used nowadays by the help of the NGOs. And these gardens, you can really apply it at homes you would like it. With this, I would like to conclude here. Really, I have skipped many things since I have very limited time, and I just can give the views of the topics only in this limited time. Thank you, sir. Thank you all.
We have just one question from the student side.
Yes, sure, sir.
So one of the students has asked that any waste which may have harmful effects or nature is dangerous in what aspects? Quantity or quality? Quality he refers to biological properties like degrading natural substances and so on. So you can see the questions in the question our space.
Sir, can you repeat it?
The question is, any waste which may have harmful effects over nature is dangerous on what aspects? Quantity or quality? He refers
If,
that yeah.
If I am saying that there is a microbe in a water and the quantity of the microbe is fused, so it is a quantity or it is a quality. Means if whether it is a like pathogenic substance or it is a non-pathogenic substance, or is it a hazardous substance or non-hazardous substance. So basically it is very important to classify that particular type of waste. If we cannot characterize that, for example, I have given example of these dioxins or furans. They are chlorinated compounds and they are known carcinogens. So their small quantity is good enough to threat the human lives. So they are not required in a huge quantity. If any waste which is like municipal solid waste, which is in huge quantity and it is not having any toxicity or any hazardous component in it, like it is not flammable or it is not toxic or it is not mutagenic, so it can be handled easily, although it is big in quantity. But if it is toxic one, then it is a threat.
Well, probably if the students are having any more questions, they will be writing to you directly, sir. Who will be providing the maybe the ID of yours. If they have any doubts, we'll otherwise we'll collect the questions and write to you, sir.
My pleasure, sir. That I'm ready to take up. There wouldn't be any issue. Since I have to squeeze it, that's why I have go in hurry. But I will respond their questions.
Yes, Rajesh, sir.
Well, sir, thank you for delivering such a informative lecture. I hope my students will follow this 3 R's principle, and please students understand reduce and reuse. They are the two important things as Sir explained, and recycle is the last step. So when you are dumping the waste, put biodegradable and non-biodegradable in separate green and blue. Okay, as Sir has explained. And Sir also explained steps involved in the integrated solid waste management like separation, processing and transformation. So Sir also has explained process of composting and vermicomposting, incineration, pyrolysis, most of the techniques. Okay, so I hope students follow this simple step what Sir has explained. Please separate that biodegradable and non-biodegradable when you are dumping the waste. So what it helps you, if you just separate them, you can avoid the contamination hazardness coming from the non-biodegradable waste. Sir, thank you for giving such a nice lecture, and I thank Cody sir and the coordinator for supporting. Somakanta sir for organizing this lecture and all other faculty members. And finally, I thank all the students. Thank you, sir.
Thank you, sir, for giving an opportunity to address your students and as well as those who have joined here.
Thank you so much, sir.
Thank you very much, sir.
Thank you, sir. My pleasure, sir.